Hey, and welcome to today's lesson. Today's lesson is about two very special pairs of angles. These are two angles that we're going to see showing up a lot. They have a great relationship and a really useful relationship. So let's dive in and talk about these two special pairs of angles. But actually, before we do, let's make sure that your vocabulary from elementary and middle school is exactly where it needs to be. So here are some terms that I know you already know, and those terms are complementary angles and supplementary angles. And down here are the definitions. You just have to figure out what goes where. So complementary angles, turns out they're two angles whose sum is 90 degrees, and supplementary, two angles whose sum is 180 degrees. Okay, so you have those terms down, and those are terms we're going to be using a lot. So make sure you remember, because I'll just use that vocabulary quite a bit. But here are some new terms for you, some pairs of angles that are really special to us. So the first is a linear pair. And if you look and use your English skills, linear, you see the root word here is line. Linear pairs, two angles that share a vertex and they share a side and they form a straight angle. So you can see right here that we have a linear pair, that this angle AOB, remember AOB, the vertex is always in the middle, that's this purple angle right here, and angle BOC, that's this blue angle right here. Those two angles form a linear pair, which means they add up to 180 degrees. Vertical angles. So what do we know about vertical angles? Well, vertical angles, and this is a really new term for you, when two lines intersect, when two lines meet each other, the vertical angles are the ones that are opposite each other that don't share a side. I always think of vertical angles as backdoor angles. So for example, in this picture, we'd say angles 1 and 3 are vertical angles, and angles 2 and 4 are vertical angles. So as you take notes, you probably have to pause so you can write these things down, and you probably want pictures involved as you take notes. So make sure that you're doing a really good job taking notes. Remember, you're taking notes for you, so you could come back to this later on and look and understand what's going on. Okay, so let's see if we could figure out why these angles are so special. Why are they so unique? Well, for linear pairs, you actually already know why. So if I gave you this picture right here, and I said find the measure, this little m means measure, of angle AOB. Angle AOB, that's our unknown, so maybe we call that x. Well, you know from angle addition that the sum of the parts equals the whole. And you can see here that x is this obtuse angle, what looks like to be obtuse, and 50 is this acute angle. But you also know the measure of angle AOC. It's a straight line. And straight angles always add up to be 180 degrees. So in this case, you could say x plus 50 is 180, which makes x 130. So what's so special about linear pairs? Well, we know that linear pairs always add up to be 180 degrees. And if we were going to be really mathy, if we were going to please Euclid, who is the father of geometry, and we'll talk more about Euclid later on in class, but to be very mathematical, we know that linear pairs add up to be 180 degrees, or we could use our vocabulary words and say linear pairs are supplementary. They add up to be 180. So linear pairs, that's one you already know. Let's go and talk about vertical angles. Well, let's think about vertical angles. Let's kind of play around with this for a little bit. So I have this picture right here for you in your notes. And if I give you one of the vertical angles in the picture above, you should be able to figure out all other three angles in that row. So, for example, in the table in your notes, I told you that the measure of angle GEF is 120. So if I put 120 degrees there, we ought to be able to figure out these other three angles. So how? Well, one thing you're going to notice about geometry is we interact with our pictures quite a bit. And here we know that this angle is 120 degrees. What about angle FEM? FEM. Well, let me just draw this picture here. If I cover up the bottom of this, if I get rid of everything down below this, you'll notice that we have a straight line here, straight across. And we know that straight angles measure 180 degrees. So what we have is a linear pair. If this is 120, what's this have to be? Well, it has to be 60. So we could say angle FE, and I think that's the letter M, angle FEM is 60. So, okay, let's keep going. I'm going to remove this and let's see what, oh, here's something else we have. If I take this and I cover up now, I cover up this part over here, let me just make that a little nicer, then notice we have another straight angle right there. So this is a straight angle, which means this 120 degrees forms a linear pair with this angle. So that would mean this angle is 60 degrees. Similarly, I could cover up this side of my picture, and you notice that we have a straight line here, and that straight line there measures 180 degrees. So if this is 60, this is 120. Again, those are linear pairs. And so if I go back and I look, angle MEH, that's this angle, MEH is 120, and angle HEG is 60. And what we could do is we could go through each one of these rows, and let me just get rid of these measurements here because that applied just to the first row. So we'll just move those over. Now we could say angle MEH, if that's 150 degrees, let's find some other measurements. Well, again, we can do the trick of covering up part of this picture and looking for straight angles. See how this is a straight angle right here? So if this is 150, this right here would have to be, well, it'd have to be 30 degrees because we know that they form a linear pair. So they're supplementary, or they add up to be 180. And similarly, we could rotate this and we could cover up another portion. Let me see. That's kind of all wonky there. Let's get that going. So if this is 150, you see a straight line here. And we know that straight angles measure 180 degrees. So if this is 150, this would be 30. And we could keep moving around here. We could cover up different parts. Okay, so if I cover up the bottom of this picture, we see another straight angle, which is 180 degrees. Whoops. And so, let me grab my pen. So if this is 30, this would have to be 150. And so by just covering up different parts of this picture and looking for straight angles, we can find all four measurements. So going to this table below, we know that angle FEM is 30 degrees. Angle GEF is 150. And finally, angle HEG is 30. And so you could keep going down through all these rows, filling in each row, one row at a time, go back to this picture, cover up the sides and mark them up. So why don't you go ahead and pause and try that, and then come on back. Hey, welcome back. Hopefully you filled out the rest of this table. You saw that these angles look like that, and these angles look like that. And so what did we learn? What did this teach us? Remember, we used linear pairs, but we were trying to figure out what the relationship is between vertical angles, or these backdoor angles. So anytime two lines intersect, we form two pairs of vertical angles. And what is this telling us about our vertical angles? Well, you'll notice that if I switch over to, say, a highlighter here, that this group, GEF, that's this angle right here, is vertical with HEM, or MEH. And you'll notice that FEM, which is this one right here, is vertical with HEG. So what did we just learn about vertical angles? Well, if you look at this yellow column and this yellow column, you'll notice something about the vertical angles. Same with the blues. And so our big idea here about vertical angles would be, big idea is we have learned that vertical angles are equal. So that's a really great angle relationship to know. So let's get in and let's do some exercises here and see if we can recognize our 4 vocabulary words of the day. I'm giving you a pair of angles, and your job is to tell me, are they vertical? Are they complementary? Are they supplementary? Or, and maybe they're a combination, are they a linear pair? So let's take a peek at angles 1 and 5. So angle 1 is this yellow angle this blue angle right there, and angle 5 is this green angle right here. What are they? Are they vertical? Well, no, they're not vertical. They're not bad. They share a side. Vertical angles only share a point. Are they complementary? Do they add up to be 90? Nope. Are they a linear pair? Do they form a straight line? They do. And if they're a linear pair, then they'd have to be supplementary. And so we can go through each of these, and this would be a good time for you to pause and to try this out and see how you do, and come back and check your answers. Okay, well, welcome back. Let's check angle 1 and 4. So angle 1, I'm going to trace out here with this green marker, and angle 4, I'll trace out with this green marker. Okay. They are not a linear pair because linear pairs need to be side by side. They need to share a side, and they don't. But they are vertical because you see that they're formed by these 2 green lines, and they're the ones that don't share a side. They're back doors, so those are vertical. How about 3 and 4? Well, angle 3 is this angle right here. Let me switch to my pen. Angle 3 is right here. And angle 4 is this one right here. Now, do they, when you look at their sides, do they form a straight line? Well, no. They're not vertical. They do share a side. But, oh, look at this box right here. What does this box represent? Doesn't that represent a right angle? So I would say 3 and 4 would have to be complementary. And finally, we want to see what we can say about angles 1, 2, and 3 together. So angle 1, which takes us here, angle 2, which takes us there, and angle 3, which takes us there. Well, you'll notice that if you put those 3 angles together, 1, 2, and 3, we get this straight line. So that means they'd be a linear not pair. Pair would imply 2. There are 3 of them, so maybe a linear triple. And of course, they would be supplementary. They add up to be 180 degrees. Okay, so that takes care of our first set of examples. And I think what we're going to do now is I'm going to go ahead, I'm going to end this video, and I'm going to let you try problems 2A, 2B, and 2C. And then I want you to come into the second video where you can check your answers, and then we'll get into problem number 3.